Hello and welcome back to our Pygame tutorials. So here we're working on our Pygame farming game. We've got a little character running around with an animated sprite sheet, and we've got our tiled background here. If you want to follow along, come along to the GitHub. Here we have github.com/whodev/pygame-farming. I'll chuck the link in the description. If you want to follow along, if you want to follow along. So today we are going to be doing some refactoring. We are going to take a look at Pygame sprites. Now, the problem with the way that we've built this so far is that we're not making use of these Pygame sprites. Here is the documentation, pygame.sprite.Sprite. What we can do is we can extend this sprite here, this sprite class, and then we get a lot of nice things included in that. One of them, the main reason why we want to do this is for collision detection. So we can have all of our sprites grouped together, and then we can see, do they collide with each other? Are they touching each other? Do they interact? If so, then we can do certain things. Things like combat. If we have an enemy and it hits us, then it causes damage. If we're throwing things, if we're shooting bullets or something like that, if we're in a map, there are areas that we shouldn't be able to walk to. So we can see, okay, if we're colliding with the ocean, don't let the player just keep on walking into the ocean. Stop the player here. This is something that we're not doing right now. So we've got some refactoring to do. Here is the documentation for pygame.sprite.Sprite, and we'll make use of this heavily. So we're going to have to copy what's going on here. We're going to have to learn a little bit. We're going to be doing some reading and trying to work this out. And we're going to refactor our code at the same time. If we take a look at the code now, it's all in this one big main.py file. We've got the player class, we've got the main game class, we've got all these constants here, and it's starting to get very, very messy. So what we need to do is break this out a little bit, and we're going to create separate files for each class. So that way we can have it all self-contained and then have the main game class import the other files, the other classes. So, I mean, let's start off with deleting this. Let's start by extracting out this player class here. We'll put the player in its own file. So let's grab this here and we'll cut that, and then let's create a new file called player.py. And then in here we can paste that in. So obviously we're going to need to import pygame here. And there's probably a bunch of other stuff we need to import. I'm not too sure what else. I mean, what are we importing here? Just system. Okay, here's one we can clean up. That's not being used. Yeah, okay. We might not actually need anything else other than pygame at this point. So we can keep it that way. Something that I think we should do is also pull out these constants and move those to a separate file. Let's call it something like config. That way we can have all of our config in one file. And when we want to change that, we just go to one place and we know that it's going to be the same for all of these places. So let's do the same thing. Config.py, and we can paste those in there. So yeah, these constants here, we'll probably end up renaming these a little bit as well. But for now we can just kind of keep them the same name, just so that we don't mess up too much when we're fixing these things up. So okay, so now we have our game class here. We've extracted out all of those constants, and we've extracted out the player. So we're going to have to import them as well. So from player imports player. Here we're going to import that player class, and from config, actually we're just going to import everything from config. So import config. Okay, so this is also going to change the way that we do things. So here where we have these constants, we're going to have to reference config now. So we're just going to have to chuck those in front of every constant that we have. And we'll do the same for the player class. So we need to import. Okay, I think that's everything. So let's check and make sure that we haven't broken anything. Okay, and it's still working fine. So that's good. Our quick little refactor done. Now we've got our separate files. It's just going to make everything a lot cleaner. Now we've got everything split out. We've got our main file, we've got the player, and we've got config. So this is just a bit neater. It's a nice little refactor for us. Let's now take a look at the Sprite.Sprite as part of Pygame. So like I said, we're going to be using the documentation a lot. And here is an example of a pygame.sprite.Sprite. Or here's a class that inherits from pygame.sprite.Sprite or extends pygame.sprite.Sprite. So that means that Pygame will treat this class here, this block, as a sprite, and it will have the same expectations of every other sprite in the game. So that means we need to adhere to certain rules. If we're going to extend this class here, it means that we need to give it some things that it's expecting. And those two things are the image and the rect. So we need to give it those properties there. We also need to call this init function here. So we call the init function of the pygame sprite.sprite. That just sets it all up. This code here is all written by Pygame. So this is all behind the scenes stuff. We can dig into it later, but for now we don't need to. And by initializing it, it sets it all up. We just need to make sure we give it a self.image. And the reason for that is when we have things in the sprite, we can put them in a big sprite group, and then we can draw all of those at the same time. So previously we've been blitting out our image to the screen. We don't need to do that anymore. We can just say, put these sprites in this group here and then draw all of them. So that's a little nice optimization for us, for our code. But we need to tell it what the image is. So this is what should be blitted to the screen. And we also need to give it a rect. These are it's the position of the object, right? So this is saying where it should be on the screen. So let's take a look at how we can implement our image and our rect in our existing player class. So we're probably going to have to change some of these variables here and the way it works. Let's add the variables that we need up here. So self image, this is a pygame surface. Self image, a pygame surface, and self rect. Now we can have this nice sort of function here. We can make use of this to get the rectangle from the image. So a pygame surface will have the dimensions already, and we just want to grab those from the image. So it just makes it a little bit nicer for us. So we can use self image get rect. So this image here. So self image get rect. Okay. Now this is complaining. No overloads for. Okay, so we missed a very crucial step here. So we need to actually add in this part here to make sure that we are extending the sprite class here. So this player should be extending this pygame sprite class. Now, in our init function here, we need to make a call to the init function of pygame sprite.sprite. So we'll chuck that in there as the first thing that we do. So call to the parent class constructor. We probably don't need to leave that comment in there. I think that's fine. A nice little optimization that I like to do is to use the super function here. So just a little thing in Python. So this super function here, essentially doing the same thing. It means we don't have to type all of that out. So we can get rid of this for now as well. This isn't going to work at the moment because this image and this rect. I mean, first of all, the image needs to have dimensions to it, so we can't just initialize this as 0. I don't think. I think we need to actually tell it how big the image should be, how big the surface should be. So we can't really do that. Um, and the rectangle, I mean, yeah, if we don't have the dimensions in the image, we can't really get that from there. But it's important that we keep these here as a reminder to ourselves that we need these variables to be set. So must set these for Sprite. Okay, so let's look at how the code's working now, because there are some things here that we're going to have to change. And the main one is around how the sprite sheets are being handled. Currently, we're using one sprite sheet here where we have all the different frames of our character. And as the character is going in a certain direction, we'll animate through all of these frames. But the image that we are currently using is the whole sprite sheet. So this one here. And then when we blit out the characters to the screen, we pass in that whole sprite sheet, and we're just using a very, very select, this rect here, we're using a very, very select part of that. So we currently have a rect variable, but what we're using for our rect is the position within this sprite sheet image. Now this is a problem because this isn't compatible with the pygame.Sprite class. What we need to have are all of these as separate images. So our sprite here, especially our player sprite and other sprites, they're going to belong to a sprite group. So this group here. So we'll create the group, we'll put all the sprites in there, and then we'll make use of this draw function here. So blit the sprite images. So by using the pygame sprite group draw, it does the blitting for us. So that's why in our class here, in our player class, we need to give it that image so that when the draw function is being called from the sprite group, it will grab that image, and that's what it's blitting to the screen. So we can't do it the same way that we're doing it now. So in fact, we're gonna remove this completely. We're not going to make use of the draw function ourselves. That's going to be handled by the sprite group. So our responsibility is to make sure that it has an image to blit out, and a rect so that it knows where to blit it out to. Okay, so what we're going to have to do is to grab the sprite sheet, and we want to slice up the frames into directional lists. Okay, so what do I mean by that? Okay, so we have our sprite sheet here, and sorry for my drawing skills. So we have our sprite sheet here, and we've got different character animations here. There's 4 in this way, 4 looking this way. So this one's looking up, this one's looking down, this one's looking left, and this one's looking right. So I mean, okay, here is the image. So this is the sprite sheet, right? Just so you know what I'm talking about. Actually, these are flipped around. But essentially, we have this sprite sheet where there's 4 different directions. So we have up, down, left, and right. And then we have 4 different frames for each of those directions. So 0, 1, 2, 3. Right? So 0, 1, 2, 3. And that's the same for all of them. Okay, so what we want to do is essentially create a data object with this. So we'll make it a Python dictionary. and we'll have the different directions, and then we'll also have each of these will have a list of the frames. So when we do our animation, we'll be able to iterate through all of these, and then give that animation of the player moving, right? So this is the object that we're trying to create here, and each of these here is going to be a pygame surface. So that when we have our player image, we're going to continuously update this image property of the class to be one of these pygame surfaces. So depending on the direction that the player is pointing and the frame of the current animation, that's what we're going to update this to. So let's call that variable frames, and we'll make it a part of the player. So it's going to be a property of the player here. And these frames are going to be a dictionary. So like we went through with the image. So this is going to be a dictionary here. We'll have the directions here, and then the frames associated with it. So we're also going to need directions, which I know we already have. So we have them here. But let's do these a little bit differently. Let's just make this a list, and then we can enumerate over those. So we need down, up, left, and right. And then that means we can get rid of this one too, because we're going to do that differently. Okay, so now we have those directions in a list here. We can make use of the Python enumerate function. So the Python enumerate function is built into Python, and here in the documentation, we can see it returns an enumerate object. So it's an object that we can iterate over. And here's a great example. So here you've got seasons: spring, summer, fall, winter. And when enumerate seasons is called, here we can see that it returns a tuple of each of these items that are in the list. So we've got 0 spring, 1 summer, 2 fall, and 3 winter. This is great because then we have this integer index that we can use in our code. So let's make use of that, and in our code we will start to get we'll start to loop over those. So let's just say for index and direction. Direction in enumerate directions. So now we're going to go through each of these, and we'll have the index here. So down will be 0, and then the direction will be the string, and then we can work with that. So we're going to start, obviously down is first in the list, so we'll have down, and then what we're going to need to do is grab each of these frames. So we've got this down row here, and we're going to have 0, 1, 2, 3. This will be our list of frames. So they're going to be pygame surfaces. So let's call that the row frames. So the direction is the row, and then the row frames is our list of pygame surfaces. So each image in that row. So we're going to have to loop again. So for I in range 4. So where does the 4 come from? The 4 comes from the number of frames that we have in each row. This is what we call, in programming, we call this a magic number, and this is bad. We don't want to do this because someone who's going to come along later on is going to see that 4 and they're going to have no idea what that means. So we really should give it a name. So let's do that now. Frames per direction. So we've got these directions here, and then how many frames are there per direction? For now, let's just chuck this. No, actually, we have our config class that we've created, or our config page that we've created. So let's just save this for now, and then we'll bring up our config file here, and then we can add this in here. Frames per direction, and that's going to be 4. Okay, so now we can make use of this here in our for loop. Okay, so we'll grab that. Sorry, just saw a bug. This should be self.directions. Okay, so now that we're iterating through so we have a list of, essentially this is just the number 4, right? So we want to do this 4 times, and for each of those times we want to grab the image here. So in order to do that, we've got our big sprite sheet, which is however big it is, the full size of it, and we need to say, okay, grab this image here, grab this image here, grab this image here, but we need to tell it exactly what those dimensions are so it knows where to grab it. And then once we have it, we'll store it as a surface, and we'll store it in this row frames. So in order to tell it where to grab that from the spreadsheet, we're going to have to create a rectangle. So we'll call this rect. I know it's the same name as this, which can be a little bit confusing, but we're only using this within the for loop. So this isn't going to be the same as the class property. It's just a temporary variable that we're using just to grab those images. So pygame rect, and now we need to give it the dimensions of the rectangle. So the first one is the eye here. So obviously we're starting it at 0, 0, 1, 2, 3. So we need to use that to start with. So this is going from left to right, and similar to how we were doing it before. If you did the sprite sheet tutorial before, we need to multiply that by the frame width, right? So we need to say that we're starting at 0 and going to the full length of the frame, which in this case I think is 48 pixels. So we start at 0 and go 48. Then for the next iteration, we'll start at 48 and go another 48, and so on. So our variable has moved to the config file now, so we can do config, and we'll just multiply that by the frame width. Now we need the height as well. So for that, we'll use our index here. Why do we use the index? Well, in this case, we're getting the height, so the direction is important. So in this case, each direction is stacked on top of each other vertically, right? So this is starting at 0, down 48. Starting at 48, down another 48. So the same thing, but just on the other axis. So again, we can times that. This in this case, it's by the frame height. In this case, it kind of doesn't matter because the frame width and the frame height is exactly the same, but just for clarity. Then at this point, so we've got the width and the height. Then we just need to round it off, and we can just do that by giving it the frame width and the frame height. Okay, so we have our rect now. This is the dimensions of the sprite sheet where we want to grab that image. So obviously we want to grab the image and we want to chuck it in here into row frames. So let's do that. And what we're going to do is we're going to make use of the pygame subsurface. So let's first of all chuck it in the row frames list. So in order to do that in Python, you just append it. So we're saying, okay, for this list here, add this to it, append this to it. And now this is where we're going to need to make use of the pygame subsurface. So this sprite sheet, we're using the image load, and with that we get a surface. And what we want is a subsurface. So it's just a section of a surface that already exists. So we can start by grabbing that sprite sheet. And then there is the subsurface. So pygame surface, there should be this subsurface function here. So subsurface, create a new surface that represents its parent. So we call that, and then we give it the rect, and we get a new surface back. So that's how we're going to we're going to give it the dimensions here and get a new surface back for each of these images, and then we store it in our list. So now it's simple. We've done all the hard work. We just need to pass in the rect. And we should end up with our list of images for each of the directions in this frames dictionary here. I had just an edit here. So as I was putting this function together, as I was putting this for statement together, I left out a very, very important part of it. So I left out this last line here. So self.frames direction equals row frames. Now, this is very, very important because it makes sure that everything that we've collected here in this part of the for loop, actually gets added to this frames variable. So without this line, we're going through, we're grabbing all the frames, we're doing everything perfectly, but we're not actually assigning it to this variable here. So we need this last line here, self.frames, which is this variable, and then the direction. So that's the index of this dictionary here, this lookup. So down, up, left, and right. And then we assign all of those row frames. So that list will all get thrown into that lookup of the dictionary. So I missed that as I was writing this. Later in the video, you'll see that I'm trying to run it and it picks the error up, but I didn't notice it until then. So if you're watching this and you're going crazy saying like, "Hey, you're missing this," I did find it later on. So here is that line there. If you're following along, make sure you add it now, just to save time, and you won't get the same bug as me. Okay, so let's handle our initial animation state, and we can start off by when the class is initialized, player's not moving, the direction is down by default. Frame, so by default it's just the first frame of the list. This one here is a little bit different. So I think maybe so we don't confuse things, because we've got our dictionary of frames here, we've got our directions, and then we've got the list of row frames within that. So I think let's just change this to frame index, just to make it a little bit clearer. That this is the index, not the frame itself. Animation timer, let's leave that as it is. Position, okay, just a little optimization here as well. Let's add double forward slashes here. So in Python, this means we're going to be dividing by an integer. If we just use the single forward slash, it would be dividing by a float. So this is just a performance optimization here. We don't need that precision of the float. So let's just simplify that. So yeah, at the start, the position of the player will be just right in the middle of the screen. So we grab the screen width divided by 2, the screen height divided by 2, and that's the position of the player. Now, we are kind of doing this a little bit differently now because we have not the position that is going to define where the player is blitted to the screen, the player sprite, but instead we're using the rect. So in our previous code, I think it's all gone now, but we were using the rect variable to define where in the sprite sheet we want to grab the image. Now rect means where the player should be in the world, or on the screen at least. So what we should do here, we can still keep track of position like this, but we'll just need to update the rect so that it is representative of that. So the position here, the player position, is going to be a vector, a 2D vector. So you've got an X and a Y, and that's where in the world it is, or where in this, where in the world it is. But we need to update our rect here to say where that should be. So let's actually let's start off by setting our initial so set initial player image and not really the position. I mean, let's just say rect, right? So we'll grab these two here, and whoops. Okay, I think I've just got rid of those from the key. Yep. Sorry, I've cut the wrong thing, but that's okay. We can just type it out. So no. Okay, so we can have our self.image, and to start off with, I think we're just going to grab the first direction and the first frame of that. So it's going to be, when we initialize this player, the first time that it ever appears on the screen, it's going to be facing down and will be frame 0, the first frame of that list. So let's just grab that. So self.image, we have our frames here. So we can just grab it from there. So equals self.frames, this dictionary here. By default, actually, sorry, we have these defaults set here, so we can just make use of that. So this is going to be self direction, and then we'll use this frame index here, self frame index. Okay, so the first ever image that we have will be direction down, frame index 0. This is kind of nice actually, because then if we ever want to change these defaults, we can just change it here rather than changing it all throughout our code. So I'm getting an error here, just in the IDE. Attribute frames is unknown. So I'm not sure why that is. We have it here, but yeah, okay, we'll look into that later. Okay, so we've got the image. Now we need to create our rect, and from this we can use self image and then get rect. Okay, so the rectangle here, the rectangle here, it's going to be 0, 0 by default. So we grab the image, but when we first create it, it's going to be 0, 0. So it's going to start at the very, very top left corner of the screen. And what we want to do is we want to update it with this position here. So really, we're going to have to update this rectangle so that it makes use of this vector, this position vector. So here in the pygame documentation, we've got pygame rect, and there's actually a nice function that we can use, or a nice property that we can use of this rect called top left. So here, the rect object has several virtual attributes which can be used to move and align the rect. So we can use this top left here to change the position of the rectangle so that it matches the position that we have for the player, and then that's what we keep updating. So let's just call our self rect top left, and we'll set that to self dot position. Okay, so now we've matched up the position of the player and the top left coordinates of the rectangle. So our event handling can stay the same for now. There are some modifications we need to do for this. We have a bug where if the player moves in a direction, a diagonal direction, they'll move faster than a single direction. But we'll look at that later. Um, this I think can all stay the same. So we're updating the direction, we're updating moving, and we're updating the position. So because it's this position that we're constantly updating, when we get to update the player here as far as animation and so on, we need to make sure that the rectangle is also being updated. So after we've been through, so okay, sorry, we did still have this rect here being updated. So let's get rid of this. Yeah, let's get rid of this because that's wrong now. So we've got an update. So if the player's moving, we iterate through the different animations and we change the frame. Now this is changed as well. So now we're calling this frame index. And we're iterating through each of those. So the frame index is going to be, obviously there's one for each direction. So when the character is facing down, the index here is 0, 1, 2, 3. So we iterate all of those. Once we hit 4, we go back and start at 0 again. So that's the animation, and that should still be working fine. But now we need to make sure that we're updating both the image and the rect, because the position, actually, sorry, the position is being updated by handling events. So yeah, in our update here, we can update the position. So update the image, and then update the position, update the rect based on position. Okay, so first of all, update the image, self.image equals, and then we'll do the same thing that we did to initialize it. So here we're just making use of those frames, of that frames dictionary with the direction and the frame index. So image equals self frames, we pass in self direction, and then the self, sorry, what was that? That was the self frame index. So yeah, sorry, that's that one there. So as we're iterating through all the frames, we're updating that. So frame index. Okay, so now that's updated. We need to update the rect as well. So self rect, and here we've already set the dimensions of it, so we don't need to do that again. It's not going to change. The player is always going to be 48 by 48, but we do need to update the top left. So this is going to be the position of the player. Okay, so we should have this all updated now. So our event handling should stay the same. So if you haven't seen the previous tutorials, what we're doing is we're first of all, we set moving to false by default. Then we check to see if there's a key that's been pressed. If it's the up key, then we move the player up. So we do that by decreasing the Y coordinate. So we do that for all the directions. So because we're updating the position here, we're changing where the player is in the world, and we just need to update the top left of the rectangle. Okay, so our player should be all fine. We need to update the main game class though, because that's going to be calling this differently. Out of curiosity, let's see, can we run this so far? I'm not too sure. No, we're not going to be able to. Okay, so this okay, sorry, this is a typo. So on line 11, we're okay. So we're creating this variable here, this frames variable, but we need to say that it's an empty dictionary here. So that is a typo. In our for loop, we forgot the colon. So where's that, line 13? So we need that in there. And we're getting closer. Key error down. So in our frames here, let's check to make sure we're doing that correctly, because it looks like it's not finding the down direction. So player line 32. In fact, this is a this is an even bigger bug. So we're not even setting it. So so we've got our frames dictionary here. We're grabbing all the row frames and chucking them in there, but we're not actually assigning it. We're not actually setting it to this dictionary here. So we need to actually do that. So after we've gone through and we've grabbed all the row frames, we need to actually update the frames variable. So self frames, and here this is where we're going to pass in the direction, and we're going to then set that to our row frames. So that's a that's a very important step that we've missed out. So yeah, okay. Okay, so now we are a step closer. We're still getting an error, so our player object has no attribute drawer. And this we can fix up in our main.py file. So there are still some changes we're going to have to do in the main.py file, but we've just gone through. It looks like the main player file, sorry, the player file with the player class, that seems to be okay at the moment. But there are things that we have to fix up in our main.py file to make sure that we're utilizing the player class correctly. So let's get into that now. So now we're going to look at the main.py file, and we're going to have to change some of the things here. So the player is going to be initialized the same way. So our game class will initialize the player, pass in the sprite sheet, and then make use of it. But we're going to change the way that these are happening here. So, okay, so handle events, we need to still do that for the player. So the main game will handle the events. It will see like, has anyone tried to quit the game? If they have, okay, end it. Then we can continue on to have the player handle the events. The same for update. So we'll still need the player to update. although we might change that later, but let's just leave it there for now. So the draw function here, this is where we're going to do things a bit differently. Now, we do have a problem in that our map here is not using the Sprite class. So I think in a future video, we'll also refactor this to make use of the pygame.sprite.Sprite. But for now, we'll leave it in here just so that we can get the player finalized, and then we'll come back to that after. So let's just leave these here. But it means we're going to get rid of the player draw because that's going to be handled differently. And we're also going to take the display flip. That's where we flip everything and write to the screen, print everything to the screen. We're going to take that out of this function here. So I'll just grab that and let's just do it in our let's just do it in our main game loop here. So that will be handled there. Now, now we've just removed any drawing of the player to the screen. So let's take a look at our game. Okay, so this is good. This is exactly what we're expecting. Everything else is working fine. So we haven't broken the map display. The tiles are still showing fine. There's no player, obviously. So the player is not being blitted to the screen because we got rid of that. We're going to do it differently now that the player is a sprite. So let me just close this. Let's go back to our main function, but I also want to bring up the documentation. So in the pygame documentation under Sprite, okay, there we go. So Sprite, what we're going to do is we're going to make use of this Sprite group. So we'll create a new Sprite group and then we'll add the player to it. And then that way we can use the draw function on the sprite group, and every sprite that's in that group will be drawn from that. So let's do that now. Let's do that here in our main game loop. Now we need to be very careful because the map is still being drawn here in this draw function. We need to make sure that the map is drawn first and then the player is drawn after that. So we keep this draw function here, but let's add the player to a group here. Now I think we should probably do that as we're initializing the game class. So we'll have ourself. Let's just call it all sprites for now, and we'll chuck everything in there. And self.player. I think we could just chuck the player in the sprite group here straight away. So actually, sorry. So we call it all sprites, and that is a pygame sprite group. And then we can add the player in there. Okay, so let's then go down. That is complaining. I'm not too sure if that's the way we do it. We might need to add them to the group explicitly, but let's see. Okay, I think that's because of how we're setting up our player class. Let's just do it the longer way. So self all sprites add, and then we can just add in self.player here. All right, let's take a look. Okay, so yeah. Okay, so we've set up our sprite group here. We've put the player in that group, and now we need to handle the draw function for that sprite group. So we can go self sprite. What did we call it? All sprites, and then draw. Okay, let's try this out. I'm getting an error here. Why is that? Missing parameter for surface. Okay, what do we need in here? So sprite group draw. Um, okay, so we're gonna have to give it the screen. So let's make sure that that is passed in. Okay, so let's see. Can we run it? Yes, we can. And our player is now moving around. So the animation is still working. The directions are still working. We still have the bug where the player will move diagonally faster. So we have to fix that. We still don't have collision detection, so we need to add that. But we can do that once we refactor the tiles to also use the Sprite class. So far so good. So I think this is working how we want it to. Yeah. So there's definitely some more refactoring we need to do. It's not perfect. There is also something else that I've noticed. So if I close this, and then we bring it up, the player is not perfectly centered in the screen. And thinking about it again, it does make sense. So we've got the rect of our player here, the rectangle that says where the player should be, and it's the top left of the rectangle that we've centered in the screen here. So as you can see, like the top left of the player is directly in the middle here, but it just makes it kind of weird. The character's a little bit offset there. So I think from what I was looking at before in the documentation, it looks like there is a center um, for the rect. I mean, let's go straight there. So pygame rect. Was there a center? Yeah, there's a center and center X and center Y. So can we just set the center of the rectangle to be the position of the player? That might work a bit better. So where was top left? So let's replace that with center. And I think there was another one as well. So here, let's again replace that with center. And we'll run it again. Yeah, that's better. So now our player starts off being exactly centered in the screen. Cool. So just a little bug there, but it looks like that's fixed that. So thanks for following along. In the next tutorial, we'll look at the tiles here. So we want to make those sprites as well. The reason being, then we can add our nice things like collision detection. We can clean things up a lot. So we've worked out how it works with the player class here. We've refactored our files and everything's looking a lot nicer. But we're going to have to go to the next step and start to add some collision detection to these objects and things like that. Then we can add other cool things as well. We can add enemy players. We could add objects. You could walk around this island and collect things. This is going to be a farming game, so we're going to need to have different objects that we can pick up and use. We're going to have different objects that we collect along the way, and different objects that we interact with. So by making use of the pygame Sprite class, we're just going to have a lot more control over how we display these things. So if you're enjoying, subscribe. Please leave a comment if you want to discuss anything. Otherwise, see you in the next video.